Fan coil unit is a device consisting of a heat exchanger coil and a fan. Fan coil units falls principally into two main types, blow-through and draw-through. As the name suggests, in the first type the fans are fitted behind the heat exchanger, and in the other type the fans are fitted in front the coil such that they draw air through it. Draw-through units are considered thermally superior, as ordinarily they make better use of the heat exchanger. However, they are more expensive, as they require a chassis to hold the fans, whereas a blow-through unit typically consists of a set of fans bolted straight to a coil. A fan coil unit may be concealed or exposed within the room or area that it serves. An exposed fan coil unit may be wall-mounted, freestanding, or ceiling-mounted, and will typically include an appropriate enclosure to protect and conceal the fan coil unit itself, with return air grill and supply air diffuser set into that enclosure to distribute the air. A concealed fan coil unit will typically be installed within an accessible ceiling void or services zone. The return air grill and supply air diffuser, typically set flush into the ceiling, will be duct to and from the fan coil unit and thus allows a great degree of flexibility for locating the grills to suit the ceiling layout and or the partition layout within a space. It is quite common for the return air not to be duct, and to use the ceiling void as a return air plenum. Fan coil units are divided into two types, 2-pipe fan coil units or 4-pipe fan coil units. 2-pipe fan coil units, as in our case here, have one supply and one return pipe. The supply pipe supplies either cold or hot water to the unit depending on the time of year. 4-pipe fan coil units have two supply pipes and two return pipes. This allows either hot or cold water to enter the unit at any given time. So, let us see the working principle of fan coil units. Assume we are in summer and the hot space need to be cooled. Once the FCU is turned on, the fan starts and the hot air in the space is sucked toward the FCU from the return grill. Air first enters the FCU through the filter. Any dust carried by the return air will stick on the filter surface, allowing only clean air to exit the filter and move forward. Hence, this filter requires cleaning on scheduled basis. This is often done on monthly or quarterly basis by simply pulling the filter by hand, washing it and replacing it back. In modern buildings with a BMS system, a differential pressure transmitter is installed on the duct transmitting the pressure difference before and after the filter. Once the pressure differential exceeds the set point, the filter is then removed to be cleaned. Filtered air moves forward toward the coil. Air moves through the fins, and chilled water moves through the tubes. The coil receives the chilled water either from an air-cooled chiller installed on the roof of the building or from a central plant. Beginning in its 2016 version, ASHRAE Standard 90.1 now requires chilled water cooling coils be designed for at least a 15 degrees Fahrenheit temperature difference between the leaving and entering water. And the leaving water temperature must be no colder than 57 degrees Fahrenheit, at design conditions. As an example, for the leaving water temperature to be 57 degrees Fahrenheit, the coil in Figure 1 is selected with a 42 degrees Fahrenheit entering water temperature. This would comply with the minimum 15 degrees Fahrenheit delta T requirement. Let us assume the entering air conditions are 80 degrees Fahrenheit dry bulb and 67 degrees Fahrenheit wet bulb, which equates to a 60 degrees Fahrenheit dew point. The air leaving the coil should be cooled to a temperature less than the dew point in order for the water vapor to condense on the coil surface and therefore remove the latent heat from the air. In our case, it is being cooled to 53 degrees Fahrenheit, which means that water vapor will be condensing out of the air to reduce its humidity. The fan coil unit will contain a purpose-designed drip tray installed below the coil with drain connection for this purpose. Normally a drain pipe is connected to this drain connection, which transfers the condensate to the nearest floor drain. The nice, cooled and non-humid air is then transferred to the space through the fan to create a comfort environment. The speed of this fan is controlled from the space thermostat by simply increasing or decreasing the fan speed. Another pressure differential transmitter could be installed along the fan and connected to the BMS system to give an indication of damaged belt in case of zero pressure difference. The thermostat also regulates the chilled water flow using this control valve, which opens to increase the chilled water flow when the space temperature goes above the desired temperature. and closes to decrease or stop the chilled water flow when the space temperature reaches the desired temperature. Thanks for watching, and don't forget to subscribe to keep updated with our new educational videos.